Okay, lesson 45, we just talked about finding excluded values on a graphing calculator with the graph or the table, so we all know how to connect that now a little better. Okay, we're going to also work, the second one, we're going to be solve word problems using rational expressions. This is going to be harder because we don't just use math just to know math, we use it to solve real-world problems. Okay, so if you wanted to, these are the steps for the graphing calculator, so if you wanted to get the steps for that, you could use them. Okay, but we're gonna. And these were the actual expressions we used. Okay, now these are the steps for word problems. Read the problem completely. It's very important we understand what the problem's saying. We have to imagine what's going on so we understand it. You need to identify the values, identify the relationship between the aspects of the problem. You have to create an equation and solve it. Okay. This is really hard. Everything's very, like, number 1 is not very hard. You just have to read it and start understanding it. But 2, 3, and 4 are the hardest, okay? And that's, you could all do it, okay? Word problems, you could do it, okay? And then 5, solve. All right? So, before we start this problem, on the street, what do you notice? What does it say? 40 what? When you see the speed limit, it says 40 what? Okay, good. 40 miles per hour, right? So what does the word per mean? What? Every, but what, I'm sorry, let me be more specific. I should ask it differently. What operation does per represent? Add, subtract, multiply, or divide? Division, okay? Okay, when I say miles per hour, you know when you look at the street sign, it says 40 miles per hour. Look up here. Okay. Okay, when I say that you had a 99% on a test, okay? 99% on a test. What does that mean? It says 99. What does percent mean? What does per mean again? Division. So 99. And what is cent? What does cent mean?
100.
100. Good. How many years in a century? How many years in a century? 100. How many cents in a dollar? 100. How many legs does a centipede have? 100. Whoa, just blew your mind, right? Who knew that already? Okay, somebody did. Raise your hand if you just learned that today. Good, you learned something. Good. Okay, so what does per mean? Divide. So when I say you got a 99%, it means divide by 100, okay? This is important. I know that this is something you see on the street, so that means you're going to go 40 miles per hour. Okay, anyways, that's just a side thing. Okay, so I'm going to read through this problem, okay? You're going to follow with me. You do not need to write this down. But you will write down the work, okay? So the aerodynamic covering on a bicycle increases the cyclist's average speed by 10 miles an hour, okay? So those are big words, aerodynamic covering on a bicycle. I'm like, what does all this mean? Okay, bicyclist. What's a bicyclist? Can you all imagine what a bicyclist is? Someone that's on the street, they wear those tight, like, shorts, and then they're like, you know, right? Okay, so... But it's saying there's an aerodynamic cover. There's people on bikes that just ride the bikes, and then did you ever see those bikes that have like that special like cover? They like put like a capsule around them, and then they're like their head is sticking out, like popping out. Why did they do that? To go faster, right? It's more aerodynamic. Okay, so will you go faster with the covering, or will you go slower? You go faster. Okay, good. So. You see how this is stuff you have to think about when you're reading the problem. You're like, oh, duh, that's what it's talking about. So it says that that covering on a bicycle increases the average speed by 10 miles an hour. That's a lot faster, right? Okay, that's awesome. So it's giving me some information. I'm going to keep reading the problem as a student. I would rate it and I'd say the time for a 75-mile trip is reduced by 2 hours. Wow, that's really fast. Okay, so it sounds like the bike could either go... It could ride the bicycle without a covering 75 miles, or it could do the same trip with a covering, but it could take 2 hours less. Wow, that's a lot faster. So now the question is asking, what is the average speed for the trip using the aerodynamic covering? Meaning, how how fast is the bike going if it's got the covering on it? Okay. So this is a harder problem, right? Gives us a lot of information. So the first thing you want to do is we need to identify, after we read the problem, we know that it's either the bicyclist could be by or ride without a covering or with a covering. So I need to organize some data here. So I like making a table, okay? So make a table like a square table. We know that the biker went a certain distance, right? Do you agree that when a biker goes, they go a certain distance? Do you agree? Okay, good. So in this case, the biker could go without the covering. They could go with just by themselves, or they could put the covering on their bike, okay? But either way, they're going to go 75 miles. Okay, do you all agree with that? Yes or no? You good? Okay, and you should write this down along with me. So put this in your notes. I'll give you a moment to catch up. And as a biker goes, does a biker go from here to his or her destination automatically? Is it just like, zap, I'm there? What has to pass? Time, right? So I need to think like, okay, there's distance, and there's time, right? Miles per hour. Hour is time. So we need to think, okay, well, we have to think about a time. So in this case, the biker is going a certain time. Do we know how long the biker takes without a covering? No. So we need to figure that out. I don't know what it is. So mathematically, I could figure, okay, it's a variable. I don't know what it is, but I can make it t for time. Okay? All right? But what if the biker has the covering? What does it say? Well, look at the second sentence. The time for a 75-mile trip is reduced by 2 hours. So there you go. Good. So t minus 2, right? We have to think about it. Does the biker go faster with the covering or slower? Good. So does that mean it takes more time or less time? How much less time?
2 hours.
Good. So how would I write that again? T minus 2, okay? So I'm going to write down, before that, t minus 2 here. Oh, sorry. Okay. Awesome. So I could find a rate. Remember, what is miles per hour? It's the distance someone went over the time. So what was the distance the person went without the covering? Well, they went 75 miles over a certain time. We don't know how many hours it was, but that's how long it took. So what's the rate for someone with the covering? What's their speed? What's the distance in the numerator? 75. Good. And I don't know where that's repeating itself. Okay, 75. And what is the time that passes for the person with the covering? What did we say? T minus 2. Good. Okay. Well, we're just organizing the info, okay? So now we have to think about the next step. It says we need to identify the relationship between the aspects of the problem, okay? The problem is asking for what is the average speed for the trip using the aerodynamic covering, okay? So we need to figure out what is the speed with the covering, or the rate, right? We want to figure out what is this answer here. What is the rate with the covering? What is this equal to, okay? Well, we need to figure out a relationship here. It tells us that the rate with the covering, okay, look at the first sentence. The aerodynamic covering on a bicycle, what does it do to it? How much faster does the bicycle go with the covering? Okay, so it means that the rate with the covering is the same thing as the rate without the covering, but plus 10 miles an hour, right? So we could write this sentence. It's saying rate with the covering is equal to the rate without the covering plus 10. We know this information now, so we could say the rate with the covering is 75 over t minus 2. So now I'm going to write down my equation. Is equal to 75 over t plus 10, okay? It's a little bit laggy today, huh? Okay. So that's the equation. Now, couldn't we do this equation? Didn't we just learn how to do this? Okay. So do we have a common denominator on the left-hand side? Does the left-hand side have its own fraction with its own common denominator? Yes or no? Yellow egg. Okay. Right-hand side. Does the right-hand side have a common denominator? No. What's the denominator under the 10? 1. So what should I do with the right-hand side? Discuss with your neighbor. Okay, what am I doing? I heard everyone say it. Multiply by what? Okay, good. So we're multiplying the right side by t. So we're doing this together. This is just like the last couple days. You already know how to do this. Oh, by the way, what's my excluded value or excluded values here before I can even start? 2 and 0. Okay, good. All right. Good. So that means time can't be 2 hours and time can't be 0 hours, okay? All right. Okay, so we got 75 over t minus 2. This is just like what we did yesterday. Okay. I got a question for you. Does the left and right side have its own separate fraction and their own common denominator? Yes or no? Yes, good. Does the left and right side have the same common denominator? No. So can I multiply by the same denominator on both sides? No. So what should I do? Cross multiply, okay? So we're cross multiplying. We got 75 times t is 75t. T times 75 is 75t. T times 10t is positive 10t squared. And then negative 2 times 75 is negative 150. And then negative 2 times positive 10t is negative 20t. Okay? Now I'm going to combine like terms. I know that there's a 75t here. I'm going to subtract it and move it to the right-hand side. But I noticed that the right side also has 75t, so that cancels out. So I'm left with 0 is equal to 10t squared minus 20t minus 150. Oh, those are big numbers. What do you notice about all my numbers in my trinomial here? They're all divisible by 5, that's true. What else are they divisible by 5? By 10, good. Okay, so if they're all divisible by 10, sorry, I was supposed to say 150. Let's divide everything by 10, okay? So what's 0 divided by 10? Good, okay? 10t squared divided by 10 is going to be t squared. Negative 20 divided by 10 is negative 2t. Negative 150 divided by 10 is negative 15, okay? Can I do an X box of this trinomial to solve? Yeah, I'm not sure why it's not showing everything here. My internet's running slow. So we got 10 minus 5 times 10 plus 3 is equal to 0. So t is equal to 5 and t is equal to negative 3. Okay, are there any extraneous solutions here? Discuss with your neighbor carefully. Are there extraneous solutions? Think about the concept. We're talking about time. T is time, right? Okay. I'll give you 10 seconds. Figure out yes or no. Are there extraneous solutions here? I need you to hear you talk. Last class they stayed over, so if you're not finished talking, it's going to take longer. Okay, so are there any extraneous solutions here?
Yes.
No. What were the initial excluded values? What were they? 0 and 2. Good. Are those extraneous solutions there? No, but I heard someone say that there's extraneous solutions. Are there? Yes or no? Okay, think about time. Can the time take 5 hours? Yes or no? Can a biker take 5 hours to do a trip?
Yes.
Yeah. Can a biker take negative 3 hours to do a trip? Is there such thing as negative time? Do you get younger when you ride your bike? Does time go backwards? No, but does time go backwards when you ride your bike? No, it doesn't. So, is it such thing as thinking about time? Is there such thing as negative time? No. So, is there an extraneous solution here? Yeah, negative 3. No, time still in the universe. Time is happening. Okay, that's just an earthly concept. Almost got me, but no. Okay, so Are we done with our problem? What is the problem asking? It says, what is the average speed for the trip using the covering? So this is just time. So we want to find the rate of the covering. So we have to plug t back into here. So let's plug in t into 75 over t minus 2. Okay? Okay, what's 5 minus 2? 3. So what's my answer going to be? What's the speed? 25 miles an hour. Okay? Write this down. Okay, so that is how you do one word problem. I know it took a while. So I'm actually going to, the homework is posted. I'm going to adjust it a little bit. But tonight's homework, you need to, you'll have a few word problems. I'm going to give you 3 word problems, and then you have some of these regular problems to solve. It's book work, okay? All right, this video I'm going to post online of what we just did in case you missed something or you didn't understand it.